If you've ever glanced at a job description for a network engineer, you've definitely seen this term, VLANs. So today, we're going to pull back the curtain on virtual LANs, taking you from the core concept to the exact knowledge you need to absolutely nail that interview and land the job. Let's dive in.
So let's start with the situation you are absolutely going to run into. Your company's growing, right? More people, more computers, more everything. The finance department is over there handling super sensitive payroll info while the sales team is hammering their CRM. The problem? They're all on one big, flat network. So how in the world do you build a virtual wall around the finance team, making their data completely invisible to everyone else without having to buy and install a whole separate set of physical network gear?
You guessed it. The answer to this classic problem is VLANs, virtual LANs. They are the smart, efficient, industry-standard solution, and we're about to break down exactly how they work. But before we can get our hands dirty with configurations and troubleshooting, we've got to build a rock-solid foundation. So let's start with the big question. What exactly is a VLAN? Okay, this is the definition you want to commit to memory for any exam or interview. A VLAN is a logical partition of a physical network. The keywords there are logical and physical. See, even though all your computers might be plugged into the very same switch, VLANs allow us to slice it up and create multiple totally separate, totally isolated networks on that one single piece of hardware. And here's a key detail. They work at layer 2, the data link layer. That means they're all about hardware addresses, not IP addresses, which is fundamental to how they keep traffic separate. To make this super clear, think about it like this. A flat network, one with no VLANs, it's like a giant open plan office. When one person shouts, and that's basically what a broadcast message is, everyone has to stop what they're doing and listen, even if it has nothing to do with them. It's noisy, it's inefficient, and honestly, it's not very secure. But with VLANs, we start putting up walls. We create separate departments. Now, a broadcast in the sales department is only heard by people in sales. Finance traffic stays right there in the finance department. And that right there is the whole point of a VLAN, to break up one giant, noisy broadcast domain into several smaller, quieter, and much more efficient ones. So how does a switch magically know which data goes where? Well, it uses a process called VLAN tagging, and the industry standard for this is called 802.1q. The easiest way to think of it is like adding a tiny digital tag or a sticky note to every piece of data as it travels between switches. This little tag just says something simple like, hey, this data belongs to VLAN 10, or this traffic is for VLAN 20. The switches then just read these tags and make sure the data only goes out to ports that are members of that exact same VLAN.
So, we know the what and the how. Now let's open up the toolkit. Because out in the real world, you don't just use a VLAN. You use specific types of VLANs for different jobs to build a network that's both secure and efficient.
All right, this table right here, this is pure gold for any interview, so let's walk through it. First up, the data VLAN. This is your basic workhorse. You use it to separate departments, like sales from HR. Simple, effective. Next, the voice VLAN. This one is so important. By putting your VoIP phones on their own dedicated VLAN, you can prioritize their traffic. This ensures call quality stays crystal clear, even if someone else is downloading a massive file. That's a perfect example of quality of service. Then there's the management VLAN. This is a huge security best practice. You put all your switch and router management interfaces on this VLAN, and then you lock it down. A normal user should never, ever be able to even ping the switch they're plugged into. The native VLAN, this one can be a little tricky. It's designed to carry traffic that doesn't have a tag. It's there for compatibility with older devices, but you have to be really careful with it, because it can be a security hole if it's not configured correctly. And finally, the default VLAN, VLAN 1. When you unbox a new switch, every single port is in VLAN 1. Your first job as a network admin is to move everything out of it. Never, ever use VLAN 1 for your actual data.
Okay, so we've got our toolkit. But why do we even go through all this trouble? Let's talk about the payoff, the real-world business benefits that make knowing VLANs so incredibly valuable. The number one reason, hands down, without a doubt, is security.
By putting the finance team on, say, VLAN 20 and the sales team on VLAN 30, you've created a hard, logical boundary. From the network's point of view, a user in sales can't even discover a server in finance, because as far as their network is concerned, it simply doesn't exist. This is Network Segmentation 101, and it's the main reason we use VLANs.
The second major benefit is a big one, and that's a serious boost in performance.
Remember our open plan office analogy?
By creating those smaller broadcast domains with VLANs, you drastically reduce all that unnecessary network chatter. This helps prevent a nightmare scenario called a broadcast storm, where traffic just spirals out of control and can literally bring your entire network to a grinding halt. VLANs are your first and best defense against that.
All right, you've got the fundamentals down. Now, let's get into the pro-level stuff. Mastering these next few concepts is what's really going to make you stand out in a technical interview.
So we've spent all this time talking about keeping VLANs separate, but sometimes they actually need to communicate. Maybe a user in sales needs to access a printer that's on the operations VLAN. A Layer 2 switch can't do this by itself. It only understands traffic within its own little VLAN bubbles. So the traffic has to go on a little trip. The switch sends the packet up to a Layer 3 device, like a router. The router looks at the packet's destination IP, sees it needs to go to VLAN 20, and routes it over. Then it sends that packet right back down to the switch, but this time it's tagged for its new destination. That, in a nutshell, is inter-VLAN routing.
Now for a really important security question. If VLANs are supposed to be these isolated little islands, what happens when a bad guy on the network tries to bypass that separation and jump from their VLAN into a much more sensitive one?
This kind of attack is called VLAN hopping, and knowing how to stop it is non-negotiable for a network admin. And the fixes? They're all about basic, solid security hygiene. First off, if you're not using a switch port, shut it down. Disable it. No plug, no problem. Use features like port security to lock a port down to a specific device's hardware address. And like we've said before, get everything off the default VLAN 1, and make sure your trunk ports are configured properly to avoid any native VLAN exploits.
Theory is one thing, but when you're on the job, you're going to be fixing things that are broken. So think of this section as your field guide to the most common trouble tickets you're going to see that are related to VLANs.
Okay, let's play Network Detective. Ticket comes in. My computer can't communicate with the server. You find out they're on different VLANs. Your number one suspect is always inter-VLAN routing. Go check that router configuration first. Next ticket, the whole network is super slow. This screams broadcast storm. Your first move is to hunt for a misconfigured port or maybe a looped cable that's just flooding a VLAN with garbage. And the most common one of all, I just plugged in my new computer and I can't get online. 9 times out of 10, the cause is simple. The port they're plugged into hasn't been assigned to the correct VLAN on the switch. Always check the port assignment first.
All right, we have covered a ton of ground, so let's boil it all down into the ultimate cheat sheet. This is your final checklist for what you absolutely have to know before you walk into that interview.
This right here is your final review. Before you go into any technical interview, make sure you can speak confidently about every single point on this list. Can you define a VLAN and explain why broadcast domains matter? Can you explain 802.1q tagging and the different roles of data, voice, and management VLANs? Can you explain not just what VLANs do, but why they're so critical for security and performance? If you can nail these points, you are going to be in great shape.
And we'll leave you with a final thought to bridge this to the next level. You now know how to build the different rooms on your network using VLANs, and you know how to create doorways between them using a router. So the next logical question is, how do you write the rules for who's allowed to go through those doorways and what they're allowed to do? Well, that's where things like access control lists and firewalls come into play. But that's a story for another time.